All right, question 18. We've got f of x equals x take 5, g of x equals 2 plus 2 on x. The purpose of this question is to sketch them being added together. Find the coordinates of the two pairs where f of x equals minus g of x. So I'm going to do this algebraically. So if we're saying f of x equals minus g of x, and that's the same as x take 5 equals minus this whole thing. So I've got 2 plus 2 on x, which means x take 5 equals negative 2 take 2 on x. I want to find the x coordinate of this and then sub it in to find y. Well, I actually think it's going to be easier to take this minus 2 over first. So I've got negative 5 plus 2. X take 3 equals negative 2 on x. Now I'm going to multiply everything by x. So I've got x squared take 3x equals negative 2. So x squared take 3x plus 2 equals 0. I'm going to factorize this to find the two values of x, or you could use a quadratic formula. This is x take 2, x take 1, because I know negative 2 times negative 1 equals positive 2, and negative 2 plus negative 1 equals negative 3. So x equals 2, x equals 1. When x equals 2, y equals, I'm going to sub it into either of the equations, but f of x is obviously easier because I've got 2 take 5, which is negative 3. So the first coordinate is 2 comma negative 3. X equals 1, y equals 1 take 5, which is negative 4. So the next coordinate is 1, negative 4. So these are my two coordinates. On a half-page number plane, sketch the line y equals f of x and the hyperbola y equals g of x. So f of x is x take 5, so it's gradient 5 at gradient 1, y intercept negative 5. Um, 2 plus 2 on x. I'm going to sub in some points. So if x equals 0, then it's undefined, so it's got its asymptote there. 2 plus 2 on 1, 4. 2 plus 2 on 2, 3. 2 plus 2 thirds. 2 plus 2 fourths. 2 plus 2 fifths. Hang on, how do they meet? Oh, it's where it equals minus. Okay. So this one's going to keep going along and along and along. Its vertical asymptote is going to be at positive 2. And 2 plus 2 on minus 1. 2 plus 2 on minus 2. And it's going to kind of... Okay. Show that as x tends to positive infinity and x tends to negative infinity. F of x plus g of x, take that, it tends to 0. So f of x plus g of x, take this thing, it's the same as x take 5 plus 2 plus 2 on x take x take 3 equals, what's that going to come out as? X take 3 plus 2 on x take x plus 3. The x's disappear, I'm just going to get 2 on x. So as x tends to infinity, 2 on x is going to disappear, dividing by bigger and bigger numbers. So add the line x take 3 to your graph. For me, that's going to be orange. X take 3 is normal straight line, gradient 1, y-intercept negative 3. That's just x take 3. This is an oblique asymptote to the curve. Oh, okay. They're going to do weird things around that. Complete your sketch of the sum f of x plus g of x. Okay. Well, let's do this the easy way. Let's pick out some points. So I'm going to pick out like x equals minus 2. When you add the things together, we're going to have 1 plus negative 7, negative 6. When x is negative 1, we've got 0 plus negative 5. Ooh. X is 0. We're going to have undefined Yep, just undefined. X equals 1. We're going to have 1 times 5, hang on. We're going to have 4 plus negative 4, which will be 0. For x equals 2, we're going to have 3 plus negative 2, which is 1. I see what's going to happen. We're going to have, did not draw this very well. We're going to have the situation where it kind of goes like that. And this one is going to go like that. Very cool.